Have you ever looked up at the sky, heard the roar of a fighter jet tearing through the air, and then wondered, after firing hundreds, even thousands of rounds, where do all those shell casings go? In war movies, you see jets diving, guns blazing, streams of glowing tracer rounds ripping toward the ground. But there's something strangely missing. You never see the shell casings fall. No rain of metal, no sound of steel hitting the earth, no sign that hundreds of pieces of metal were just fired from the sky. So, where did they go? Some people believe the casings simply burn up in the air. Others think they self-destruct. There's even a theory that the military just doesn't care and lets the metal fall back to Earth. The truth isn't mysterious, but it's far more dangerous than you might think. A single 20mm or 30mm shell casing weighs anywhere from a few hundred grams to over half a kilogram. That doesn't sound like much, but when it falls from several thousand meters up, it's no longer just a shell casing. It becomes a deadly piece of metal, powerful enough to dent rooftops, shatter car windshields, punch through sheet metal, and kill if it strikes a person. All it takes is one small piece of metal falling from the sky to turn into a disaster. And that's only the danger on the ground. For a fighter jet, ejecting shell casings outside the aircraft is even more dangerous. If those casings aren't properly controlled, they can ricochet back into the fuselage, strike the wings or air intakes, or be sucked straight into a jet engine. It only takes one small piece of metal entering the engine to cause serious damage, or even a catastrophic fire. But there's another danger that far fewer people think about: aircraft balance. A fighter jet doesn't just carry fuel and weapons, it also carries hundreds, sometimes over 1,000 rounds of ammunition. Take the A-10 Thunderbolt II, for example. It carries more than 1,100 rounds of 30mm ammunition. When those rounds are fired, the aircraft becomes nearly 400 kilograms lighter. Now imagine that happening in just a few seconds. If the shell casings are expelled outside the aircraft, unevenly, asymmetrically, not as originally designed, the aircraft's center of gravity can shift suddenly. At high speed, and especially during low-altitude flight, even a small imbalance can cause violent vibration, loss of stability, or a dangerous deviation from the flight path. And this isn't theoretical. During a live-fire training exercise by the U.S. Air Force, a fighter jet experienced a malfunction in its shell retention system. A large number of shell casings were ejected as the aircraft accelerated away from the target. Fortunately, they fell over an uninhabited area. But inside the cockpit, the pilot immediately felt something was wrong. The aircraft began to shake violently. Its flight path suddenly veered. It felt as if one wing had been struck. Only through lightning-fast reactions and extensive flight experience was the pilot able to regain control. The post-flight report was clear. Uncontrolled shell ejection poses a serious danger to both the aircraft and the ground below. From that point on, shell handling systems were no longer a minor detail. They became a mandatory standard in the design of modern combat aircraft. So, how do fighter jets actually deal with shell casings? There isn't just one solution. In reality, there are four main approaches. 1. Fully enclosed internal retention. Imagine you're driving on a highway, and every time you hit the brakes, a chunk of steel drops onto the road behind you. No one would accept that. For fighter jets, the consequences are far worse. Some aircraft are designed around a very simple principle. If something can become deadly when it falls, then it must never be allowed to fall at all. So, after a round is fired, the shell casing doesn't exit the aircraft. Instead, it's pulled back into the system, guided through internal channels inside the fuselage, and stored in a sealed compartment. No rain of metal. No danger to the ground below. No risk to the aircraft itself. The A-10 Thunderbolt II is the most famous example. Its cannon fires dozens of rounds per second, yet every single casing is retained on board. Because when you're firing hundreds of kilograms of metal in just a few seconds, the danger isn't only the projectiles leaving the aircraft, it's the sudden loss of mass. Keeping the shell casings isn't just about safety, it's how the aircraft maintains balance and survives. 2. Controlled directional ejection. Not every aircraft has the space to carry around a flying metal trash bin. So what's the next solution? Eject the casings, but do it in a controlled way. Think about wastewater discharge from a ship. You don't just open a hatch at random. You route it through the right pipes, in the right direction, at the right location. Aircraft work the same way. Shell casings are expelled through a precisely engineered ejection port. The casing's trajectory, surrounding airflow and aircraft speed, all of it is calculated in advance. Firing is only allowed when the aircraft is over the ocean, over a training range, or inside a controlled area. No clearance, no firing, because it only takes one piece of metal bouncing the wrong way to get sucked into the engine. And when that happens, the story ends very quickly. 3. Caseless ammunition. So why not eliminate the shell casing altogether? The idea is real. It's called caseless ammunition. On paper, it sounds perfect. No casings falling, nothing to collect, nothing to eject. But here's the problem. A shell casing isn't just waste. It plays a critical role. Containing pressure, dissipating heat, protecting the feeding and firing mechanisms. Remove the casing, and you have to solve all of those problems in other ways. For infantry weapons, that's already difficult. For large-caliber aircraft cannons, it's almost impossible. Even today, caseless ammunition remains a technological dream, not a practical solution for modern fighter aircraft. 4. Free ejection. Nearly obsolete. In the past, when regulations were far looser, some systems simply dumped shell casings overboard. No complex calculations, no concern for what was below. But reality hit back. Casings fell near populated areas. Metal struck aircraft structures. And there were cases where jets nearly went down because of a single piece of debris. Today, this approach has almost disappeared. Not because technology can't do it, but because the cost is simply too high. So when you see a fighter jet open fire and no shell casings fall from the sky, that isn't magic. It isn't secret technology. It's the result of physics, advanced military engineering, and hard lessons learned through real accidents. In modern warfare, even a small piece of metal can be lethal. And that's why shell casings from fighter aircraft are never allowed to fall at random. So what do you think? Which approach is the most optimal? Leave a comment and let me know. Thanks for watching, and I'll see you next time.